part 4 of the solar system note packet. So this is the last segment. So find part 4. It should be on page 12. Okay, page 12 and about a third of the way down. Part 4 of 4, solar system debris. So what you're seeing on this first slide is an asteroid we saw in the last set of notes called Eros. It's about the size of Manhattan in New York. That means that if this asteroid ever hit our planet, it would probably cause an extinction like the one that hit 65 million years ago when the dinosaurs died off. Very few large organisms on the surface would survive. Maybe some people would live if they were down inside caves, maybe, or if they were far away from the impact site on like the other side of the planet and had lots of food. Only then maybe would they survive, because it would throw up so much debris into the atmosphere that it would block out the sun and all the plants would die, and then the whole ecosystem would shut down, and it would be pretty much a life ender for humanity as far as we know it. So, but the reason I use this one as the title page is because this is the only one we've ever landed on. We've only landed on one asteroid, and this is it. So, and we have plans to do other things too. We've landed on a comet too. I'll show you that in a little while. All right. So why are objects like Eros, like this one, why are they called near-Earth asteroids? That's this question you have on the first slide. Why do you think it's called a near-Earth asteroid? Kind of makes sense just out of context that it comes near the Earth, close enough for us to get to it. And the picture on the right is actually what it's doing as it's flying through the space around the sun. It's spinning like that. All right, so how did this asteroid belt form? The asteroid belt that exists between Mars and Jupiter. And there's a question, what force prevented a 9th planet from forming? So pay attention to that, okay? So within the first 100 million years of the sun's birth, that's not very long because we're working on year, 4.5 billion. Protoplanets, remember the baby planets, they agglomerated from a circumsolar disk. And you see that in that picture. That's what a circumsolar disk means. Circum just means circumference or surrounding, around. And it's a disk, like a record or a CD, of dust and gas. So it's that, it's that shape. And then, of course, that word accretion, we learned, where gravity pulls pieces together until finally all those tiny pieces make up a big piece, and then a whole bunch of big pieces make up a planet, and then a few of those pieces would make a star. So when this was happening, Jupiter developed nearby, but it interfered with the formation of another planet in the asteroid belt region. Jupiter's gravity made the particles speed up instead of slowing down. So let me read this to you, okay? I'd like you to read along with me as well. So this is the question for slide 2 and 3. The formation of the asteroid belt is a result of Jupiter's quick formation and gravitational domination in the early solar system. So Jupiter's gravity took over, dominated that part. If you look at the picture on the right here, that part of the solar system, and made objects go faster than normal speeds. So that made them, when they hit each other, that made them break into smaller pieces instead of sticking together to make bigger pieces. And that's called an erosional process instead of an accretional process. See the underlined words there? So the objects in the area of the asteroid belt will not coalesce or come together into a planet. That's why we have an asteroid belt, because of Jupiter's gravity. So we're on slide 4. So far, the largest asteroid found in the asteroid belt is as big as the state of Texas. It has been named Ceres, which has a diameter of about 1,000 kilometers. It's the only dwarf planet that's located in the inner solar system. Lots of other dwarf planets exist outside, where Pluto is and beyond. But this is the only one that's considered big enough to be called a dwarf planet and not be orbiting some other planet. So, if something orbits another planet, it's called a moon. Well, this doesn't orbit another planet. This is just in the asteroid belt, and it's about the size of a moon. It's huge. So asteroids can be a few feet to several hundred miles wide, and the belt probably contains at least 40,000 asteroids that are more than a half a mile across. And this is an artist's view, of the asteroid belt, with Ceres shown there. If you were perhaps like flying through the asteroid belt, this is maybe what you'd see. Kind of a view like this. So asteroids can be rocky or metallic. They can be made of rocks or metal, like we talked about in the last slide show. And they orbit the sun, but they're too small to be planets. Many of them are known as minor planets. 16 asteroids have a diameter of 240 kilometers or greater. 240 kilometers is a little over 100 miles. So, like the distance between here and Tallahassee, it's about 100 miles, 240 kilometers. They have been found inside Earth's orbit to beyond Saturn's orbit. And most, however, are contained in the main belt. That exists again between Mars and Jupiter. Now, some of these orbits come close to Earth, and some of them hit Earth. Maybe some of you have actually seen a shooting star. A shooting star is a meteor, a tiny asteroid that pretty much just burns up in the atmosphere. It never hits the surface, a shooting star. But some of them are big enough to hit the surface. This one that landed near Winslow, Arizona, about 50,000 years ago, is probably one of the best preserved examples of a meteor crater on Earth. And the reason is, it's the Barringer meteor crater. The reason is we don't get a lot of rain out there in Arizona. It's kind of deserty, so there's not a lot of erosion. And so it didn't wash away or the sides or fill in with water to make a lake or anything like that. So it's very well preserved. You can actually go down in the bottom there if you were a scientist. You can't. Normal people can't go down in there. You can go along the rim and see here's a road leading up to this building. This is actually a museum, and it's really neat. And you could hike around the whole perimeter of the thing. It's about a mile wide and almost as deep. So, but anyway, if you go down inside the middle, you can still find pieces of the original asteroid that hit. And it was the size of about a Greyhound bus. So a little bit bigger than a school bus. And it came in at almost a direct straight down to the Earth path because the crater's equal on all sides. It's pretty neat. And about 50,000 years ago, so there were people, human beings, living in North America 50,000 years ago. Natives, and that came over from Asia. So pretty interesting that people saw this happen. Anybody living nearby was killed, of course. Really close, but if you were probably 10 miles away, you'd probably be fine. Now, to get to Winslow, Arizona, it's actually not that far. It's only a little over a day's drive. Probably take you 2 days to get there. First day you'd stop in Texas, and the next day you'd be in Winslow, Arizona. So if you ever wanted to go see this, I've been there. I've driven there, took my family there about 13 years ago. So we stood on the edge of it. It was really neat. So if you went to an asteroid, not an asteroid, crater like that one, and speaking of those craters, by the way, you can find, if you go on Google Earth and other places, you can find other meteor craters around the planet. This isn't the only one. There's a real big one up in Canada. So if you went to an asteroid, actually flew to an asteroid and landed on it, you would realize that the gravity is very weak, because gravity is related to mass. So the more mass something has, meaning the bigger it is, the more atoms it has, the more gravity it has. But these aren't very big. You're used to Earth's gravity. You know, it's pretty hard when you hit the ground. It's pretty strong. But on most asteroids, you could probably just jump off. If you were a good jumper, you probably just spring right off and jump off. You might never come back down again and just go out to space. On an asteroid, it wouldn't look flat. You know, when you stand on the Earth and you look at the horizon, it just looks flat, right? On an asteroid, it would not look like that. It would be very curved. You'd see it curve away on all sides. It'd be very disconcerting. It'd be very, very strange to be standing on an asteroid. And this picture is the 253 Matilda asteroid. It was flown by and pictures were taken of it, and you can see that crater, that one crater is 20 kilometers wide. We talked about this one, 243 Ida, and it has its own little satellite, its own little moon called Dactyl. This was taken by the Galileo spacecraft on its way to Jupiter. Asteroids are lumpy. So again, we're on slide 10, so we're on page 13 in the middle. Asteroids are lumpy, not smooth and round like planets. On a small asteroid, you could walk around the whole thing in a few hours and be right back where you started. The surface would be hilly and pockmarked. That means a whole bunch of little holes with craters. No air, no atmosphere, because it doesn't have a strong enough gravity to hold gases to its surface. No clouds, no water. But I take that back, actually. There is a little bit of water in the rocks itself. And that's a whole other story. But it's frozen and you can't get to it. It's not liquid and it's deep inside. So someday astronauts might go there to study them or even mine the metals and ores that they contain. Certain asteroids that come near Earth would be easier for humans to reach than even the moon, because you wouldn't need a lot of fuel to land on it. On the moon, you need a lot of fuel to land and you need more fuel to take off. On an asteroid, you could pretty much just spring off and take with you whatever you want, all the precious metals and stuff home. So this is another view of when the Shoemaker space probe landed on Eros in February 2001. And it captured those images as it landed. And what does NEAR stand for? This is a question on page 13, slide 11 through 14. You can see on the top, it stands for Near Earth Asteroid Rendezvous. So it was a mission name. So what they did was they found an asteroid that was coming near Earth and they rendezvoused with it. They met it and landed on it. So this is an animation, when actual pictures just put in a sequence that show the space probe flying over the asteroid and getting ready to land on it. So you can see the asteroid is really lumpy, and this thing is the size of Manhattan. Imagine just a whole city spinning in space. Those little bumps you see are the size of buildings. And then it touched down right there on the edge of that crater. Question: what instrument enabled scientists to study the elemental composition? A gamma ray spectrometer. And they were able to retrieve data for a period of 7 days after the spacecraft landed. And they gathered data on what the asteroid was made of, both at the surface and just below the surface. And you can see the pictures on the right as it got closer and closer and then landed. Kind of soft crash. It wasn't a perfect landing, but it was pretty good. Remember what I said? It was like trying to hit a moving bullet with another bullet. That's how difficult it was. And then you can see where it was orbiting very close and then landing on it. It was obviously sending this information back to Earth via a radio signal. Okay. So now we're on slide 15 and we're talking about OSIRIS-REx. So OSIRIS-REx it sounds like a dinosaur, right? But it sounds like, it means Origins, Spectral Interpretation, Resource Identification, Security Regolith Explorer. That is a mouthful, but it arrived in 2018 on the asteroid Bennu, and it slipped into orbit at the close of that year. Since then, it has mapped the asteroid's rocky surface in great detail in order to inform the selection of sampling sites. So what it did was and then on two years later, OSIRIS-REx gently touched down. So that's what was special about this mission, is that it touched down just last year, just a few months ago, and it's going to bring back debris from an asteroid for the first time. So this is it touching down, and this is the first time anything was, besides humans bringing rocks home from the moon, which we did back in the late 60s, early 70s, this will be the first time that we ever brought anything else back from space. We don't have anything of Mars, we have nothing from any other planet or that we visited, but now we're going to have pieces of something else from space brought home. That's pretty cool. And that was the OSIRIS-REx spacecraft. Okay, now we're on to comets, slide 17. And this is pretty much the last thing we talk about is comets. So what are comets? They're ice-rich bodies, meaning that they're dirty snowballs. That's really what they are, okay? They're ice-rich, meaning they're full of water, but they also have rocks and dust and other particles like that, all gas, all trapped inside. They become prominent or exceptionally visible when they get close to the sun. And the heat from the sun causes their trapped gases, called volatiles, to sublimate. Sublimate means go directly from a solid to a gas, skipping the liquid phase. So a lot of big words there, but you understand. You can see a comet much better. You can see its tail when it comes near the sun. Why? Because the sun is hitting particles off of it. That's pretty much what you have to know. So, and that's a picture of a comet McNaught in 2007. The comets are named after the people who discovered them, which is pretty cool. All right. So remember, the most visible and distinctive feature of a comet is its coma, which is the head of the comet, and the tail. Okay, the coma, and the tail. But most of the comet is contained in this tiny central nucleus. Tiny well, not, I don't know, tiny, they could be as big as a state of the United States. Well, not, no, I take that back, not that big. A city. They can be as big as a city. So, but you don't usually see them until they come close to the sun. Now, comets can, so turn the page, we're on page 14, the last page, slide 18. Comets do some pretty interesting things. This is the comet Shoemaker-Levy 9. In 1993, it was discovered, but in 1994, it broke apart because it flew too close to Jupiter's gravity. And we already know that Jupiter's gravity does some pretty amazing things to objects that come by it. Many of Jupiter's moons are captured asteroids, and it broke up the 9th planet and made it an asteroid belt. So when this comet came by Jupiter, Jupiter's gravity ripped it apart into pieces. And you can see all the pieces labeled A through W. And then they crashed into Jupiter. Jupiter pulled them in. And you could see what it did to Jupiter's surface. Boom, 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 like bombs. And then weeks later, there were like scars in the clouds from the impact of this comet, of these comet pieces into the surface. It was kind of cool to see this happening. So a comet's tail, number 19, slide 19, will always point away from the sun no matter which direction it's traveling. This is very confusing to some people. Even though the tail is even though the comet is moving away from the sun, the tail will be in front of the comet. Because what is the tail? The tail is the solar wind blowing the surface of the comet away. So it's always going to point away from the sun, no matter what direction it's traveling. And that's due to the sun's solar wind, the sun's radiation coming off. And you can see in these pictures how the sun is over here. This comet is moving in this direction, but the tail is also in that direction. The tail is like in front of the comet. It's pretty wild. And comets have two tails. And this is an example of one, the comet Hale-Bopp. So two people discovered it at the same time, and they both got credit for it. So many times comets and things are discovered by amateur astronomers with their own telescopes in their own backyards, not people who work for, not scientists. So the two tails are the ion tail and the particle or dust tail, okay? And both of them are because of the sun, but one is caused by radiation pressure and the other one is caused by just different kinds of sun particles, okay? So there's an ion tail, which is charged particles, and a dust tail, okay? And you were supposed to write for this slide, in your own words, describe what the two tails of a comet are made of, okay? Now, where do these comets come from? Because there's lots of them. There's lots of comets. Where are they coming from? They're different than asteroids, so we know they don't come from the asteroid belt. So, according to mathematical theory, comets come from very far away in the solar system, as far away as 100,000 astronomical units. Remember what you do to find out how many miles that is. You multiply by 93 million. So in this picture here, the solar system is buried deep in the center. In the center of this cloud called the Oort cloud. And then there's also another structure out there called the Kuiper belt. The Kuiper belt and the Oort cloud. See, so this white dense part is the Kuiper belt, and then there's a less dense cloud. So it could be billions of comets that exist out there from the creation, that have been around since the creation of the solar system. And sometimes they bump into something and get pushed into an orbit that brings them close by, and we see them. And so here's the Kuiper Belt. This is slide 22. Some comets may come to the solar system from closer than the Oort cloud. They come from the Kuiper Belt. And the place, so make sure you put, I guess that name's already on your notes, so just rewrite it. And you could see Neptune's orbit and Pluto's orbit. They kind of crisscross each other. And then region where objects have been observed out here, and then they think that it continues to go out really far. So potentially more objects. So there's potentially billions of objects out there. Comet type dirty snowball objects. And you can see this is a really up close view of a comet. It kind of looks like a snowball rolled in dirt. And this is Comet Bennu, only about 3 city blocks wide. So this one's not that big, but weighs about 80 million tons. It regularly crosses Earth's orbit and will come perilously close to Earth in about 150 years. Perilously means close enough that if we don't watch it, who knows, it might come close enough to get pulled into our orbit. And on its surface, you can see, so this is a blown up version, close-up view of one of these rocks over here. So there are giant boulders on the surface that were pulled in by gravity and just sticking to it. You can imagine this thing just flying through space, and just other smaller rocks come, and when they hit it, they just land on it and stick to it. That's called accretion. And they get just bigger and bigger over time, unless something big hits them and they break apart, or they fall into a planet or the sun. And on November 12th, 2014, Rosetta, which was this, space probe, dropped off this smaller lander called Philae. And it became the first spacecraft to land on a comet. And it landed on this comet right here. So what was special about the Rosetta space probe? First probe to land on a comet. And here's the last slide, and this ends our whole packet of notes. So you can scan these pages using the Notes app on your phone and submit one PDF file, okay? So here's a question for this slide. Would life on Earth be the same if debris this large, space debris, that big, struck the Earth? Why or why not? Okay, so we talked about that in the beginning of this slideshow. So you explain, logically speaking, why or why not, okay? Pretty scary to think about, but the end.